Okay, chaps, so this lesson we're still working with radians and we're going to learn two formulas to calculate areas. Areas of what? Maybe I should really start with by reminding you what's the definition of the radian, okay? The angle in radian, theta, okay? Let's say this is theta. In radian, that's going to be the arc, the length of the arc, divided by the radius, okay? The arc, in this case, let's say this is the arc, AB. If I divide it by the radius, let's say it's R, that's going to be the angle in radian, okay? Now, I just want to show you, I didn't show you last time, but what you will get in your formula sheet, okay? In the formula sheet, you will get something similar to that, okay? Yeah, I'll write down, you'll get theta, the arc they use is letter S for some reason, okay? Divided by R. So what they're going to show you, what you're going to get in your formula sheet is this, but just manipulate it. You'll get S equal R theta. Okay? So in other words, if you want to know what your arc is, it's simply the radian times the radius. Okay? Now, with this in mind, with theta and radius, let's find out the area of two different items. The first one is a sector. Sector AOB. What is a sector? It's basically like a pizza, like the pizza slice. Okay? This area. I'm going to do it like that. Okay? So we're looking for that area. In fact, I'll tell you what the formula is, but we're going to also prove it. Okay? It's going to be half times r squared theta. Okay? Half times r squared theta, the area of the slice of pie or pizza. How are we going to do it? Okay. What will be the area of full circle? Okay? If I ask you what's the area of this full circle, I think you'll all be able to tell me that's simply pi r squared. Okay? Right? I'm just going to pause here to make sure I'm using the same notation. Okay. Yeah, all good. So now, if the whole area of the circle is pi r squared, what will be the area of this pizza slice where the angle is just theta? How are we going to do it? What we're going to do is, let's use an example. Let's say I've got a slice of pie or a slice of pizza which is, okay, I'm going to use in degrees, in radians. So let's say 1 radian. No, not 1 radian will be a little bit tricky. Let's say 2 radian. Okay? So also 2 is going to be a little bit difficult. Let's say 3 radian. Let's say 3 radian. Okay? 3 radian will be much bigger than that, but never mind. And I want to find out what's the area enclosed in this sector. Well, let's think about it. Okay? Full circle will be pi r squared. Okay? Now, the angle, if the angle was 2 pi, that's a full circle, it will be pi r squared. But the angle is not 2 pi, it's 3. So what I'm going to have is 3 over 2 pi, okay? 3 over 2 pi is like the fraction of the circle. The fraction of the circle is this 3 radians divided by 2 pi radian, because you remember from last lesson, in a full circle there's 2 pi, okay? So 3 over 2 pi, that's the fraction of the circle, and then I just time it by the area of a full circle, pi r squared. That is going to be the area of the sector. So if I rearrange things slightly, it will be 3r squared over 2. Okay? Now, what I'm really interested in this case, what is the formula for when the angle is theta, not just 3. Let's say the angle is theta. So what did I do here? Look, I took the angle, divided by 2 pi, and time it by pi r squared. So I'm going to do the same thing here. I've got the area of full circle is pi r squared. So the area of sector with angle theta, when the angle is equal to theta, is going to be pi r squared, the area of a full circle, times the fraction of the circle. What's the fraction of the circle? Theta, divided by 2 pi. Okay? Because the angle is theta, so it's some kind of general angle, divided by a full circle, which is 2 pi. What can I do here now? I can cross cancel 2 pi's, and then what am I end up with? Half r squared theta. You see? The formula that I tried to prove it. Okay? So that's about that. Okay? Now, let's say I want now to find the area of the triangle. Okay, that triangle at AOB is that. It's without this little bit. It's just a triangle. Now, there's a rule that you learn in I can't remember if it's grade 11. I think very possibly so. It's called the Sine Rule. And, you know, there's three ways of calculating areas in a triangle. One of them is the sine rule. Is there three? Oh, I think there's only two. But only one of them is the sine rule. And the sine rule will tell you that, okay, maybe I'll draw a triangle here, another triangle, just a general triangle, okay? So let's say this is A, B, C, and this angle is A, okay? So let's say I have the three sides. I've got A, and this side is, it's called, yeah, I'm getting confused a little bit. Okay, let's get rid of this. So let's say this is angle A. We'll call this angle, you know what, we'll call it angle alpha, okay? And let's say this is A, B, and C. So the sine rule will tell you the following. The area of a triangle will be equal to half, is it half? Yeah. It's half times the product of two sides, AB. Okay, so I'm doing half times the product of two sides, A and B, times sine the angle in between. Okay? So if you've got two sides and the angle in between, you do half times A times B times the sine in between. If I don't have this triangle of this angle, then I can't do half times A times C. I need also the angle in between. Okay? So that will be the sine rule to calculate the area of this triangle. Let's apply it now to find the area of this triangle. Okay? So I need two sides and the angle in between. Well, I've got this side, this is the radius. I've got this angle is theta. Then obviously I also know what this side, it's also going to be the radius because, well, that's radius, okay? So what's the area of the triangle? It's going to be half times multiplication of both sides. R times R is R squared times sine theta. Okay? So these are the two formulas, okay, that you will also have in the formula sheet. Area of a sector of a circle and the area of a triangle. Okay? Sine rule. Okay? I'll pause here and make some space. Okay, and then one more formula that the textbook gives you. And often, as you'll see in these exercises, what you're asked to find is not the whole sector, the pizza slice, not the triangle. You actually want this shaded area. And they show you a formula for that. Okay? Now, I don't think it's a good idea to remember this formula, but you need to know how to get there. So if I want to find out the area, the shaded area, I don't know how to call it, this bit, the leftovers, okay? How would I find this shaded area? Well, if you think about it, it's basically going to be the area of sector, okay, of this whole pizza slice. Okay, I'm going to draw it like this. Okay, of the pizza, minus the area of, correct, the triangle. Area of triangle. If you take that minus that, you are going to get the area, the shaded area, that little bit here. Okay? So all we got to do is just put these formulas, okay? So the area of the sector is half r squared theta. Area of the triangle is half r squared sine theta. And then I'm sure your factorization skills are good. Okay? You can see half r squared we can get out. Okay? And what we'll get is theta minus sine theta. Okay? So that's another formula that, that they give you there. If you want to find out the area, there's no name for this, but you can use this formula. But I would seriously recommend not to try and remember it. You might just get it wrong. Just use, and you'll get these formulas. You don't get that formula in the formula sheet, but you get these two. Just remember what they mean, and you just do one minus the other to get this other one. Okay, so now we're going to solve one example. Okay, so we'll start with a couple of very simple examples. We've got a segment here. The angle is 0.8 in radians. The segment area is 28.9 centimeters squared, and we asked to calculate R. So it's a very, very simple, substituting whatever you know in this equation, okay? So the area of the sector is 28.9, half time R squared, and the angle is 0.8. Okay? So we can rewrite this very quickly as 28.9 equals 0.4 R squared. Write it again as R squared equals 28.9 divided by 0.4. And then to get the answer, I'll write it here, R square root 28.9, 0.4. Need to put that in the calculator. They got 8.5. Now, to get full answer, especially for science, guys, I'm very, very sensitive to that. You got to make sure you got right units. So if I work with centimeters squared, obviously the answer will be in centimeters. Okay, that's pretty easy. Okay, the next question is a little bit tricky. So I've got a plot of land. Let's say I've got a plot of land. And it's, again, this kind of sector pizza-like shape. I know that the radius is 55, what is it, in meters, I think. Yeah, 55 meters. The radius, all right, is 55 meters. Now, I've built a fence around it, okay? So I've got an arc, well, I've got a 55, I've got a 55, I've got some kind of arc length, let's call it S, in the same way as the formula sheets. I don't know what it is. But I know that the whole fence length is 176. Now, they're not asking for S, the arc. That will be quite easy. What they're asking is for the area. So this is a case of going through two equations. Because I think very easily you can find what S is, right? Because 2 times 55 plus S is 176. I think you guys you understand very quickly, right? 2 of those plus S is 176. So that means S equal, how much is that? 110? Is that 66? Yeah, 66. Okay. So once I know the arc, what do I do now? Sometimes you might be a bit stuck. So you got to ask yourself, all right, I want to find out the area. Okay. What is the area? The area of a segment is half time R squared theta. Now I know what R squared, I know what R is. R is 55. So I'm sorted with that. So 55 squared. What I'm missing in this here is the theta. But I didn't get the theta. What I did manage to get is the arc. So you've got to ask yourself, is there another connection? Is there a connection between the arc length and the angle? And the answer is absolutely. Okay? The arc length or the radian is basically the arc divided by the radius. This is my first formula that we learned this term. Okay? Or S equal R theta. So that means that 66 is equal to R. What is R? 55 theta. So theta is 66 over 55. Okay? Which comes out as 1,2 radian. Okay? Now I can take that 1,2 radian and plug it into the formula of the area. 1,2 radian. Okay? Because that's what I was missing. I had the radius, I just didn't have the angle. And I will get 1,815 meters squared, because I work with meters here, that's going to be meters squared. Okay? Now, just working through this example, I realized something very important that I didn't really talk about earlier, and I must talk about it now. When I calculate area of the sector, okay? If I work, like I said here, if I work with centimeters, I'm going to get in centimeters squared. If I meters, I'm going to get in meters squared. But what is very important, and I didn't mention it, very naughty of me, is you have to work with radian. You have to work with radian. You can't work with degrees here. If you work with degrees, you're not going to get the answer because, well, I don't have it here, but when we develop this formula, we use this connection. The theta is the arc over the radius. We used it somehow, I can't remember, but we used it. So if you go and then use it in degrees, you'll get something, you'll mess it up. It will be completely wrong. And now again, when I'm thinking about it, what do we use here? Are we using radian or degrees? When we use the area of the triangle, half r squared sine theta, can we use radian or degrees? If you think about it, and I talked to you about it yesterday in the lesson, okay? Because it's under sine, you can use either radian or degrees. But you've got to make sure you use the right choice on your calculator. If your calculator is currently, the function is on degree, then you must put theta in degrees. If you're working with radians, and I'll show you how to do that, then you must work with radians. So here we can use radian or degree. But make sure using the function of the, using the definition of the what the calculator is on. Okay, I'll pause here, clear up, and we'll do one last difficult question. Okay, so this is our last example, and it's a bit longer and more typical what the sort of stuff that you eventually going to have. So I've got half a circle, okay? This is the center of this half a circle, stretching radiuses, 3 radiuses here. This is the angle theta, and this is a shaded area. We'll call it shaded area. Okay, just a shaded area. You see, it's basically what you have when you take the segment and you cut off the triangle, you get the leftover. That's the shaded area. Now, what they tell you here, that area of triangle AOC, the area of this triangle, okay, maybe I'll do it in blue. The area here, write it in blue as well, area of triangle AOC turns out to be 3 times the area of the shaded area, okay? And they are asking to find, what they're actually asking, show that, okay, they need to, they're asking us to show that this relationship exists. 3 theta minus 4 sine theta equals 0. Is that right? Yeah. We want to show that, prove that. Now that looks like what is going on here. Don't get confused, don't freak out. I mean, they're asking us, in that question, they've got the shaded area and the area of the triangle. So let's try and calculate it, okay? Now, let's start with the area of triangle. So we're trying to find out area of triangle AOC. We're not going to find an answer in terms of number, but we're going to find an answer in terms of theta and r, okay? Now, this, what do I need? I've got 2 sides, right? It's the area of the triangle is half times the size, which in this case are just 2 radiuses, so half r squared, times sine, the angle in between them. But don't just write here sine theta, because this angle is not just any theta, it's the angle in between them. But the thing is, the theta here is not the angle in between them. You see, you can't just put in sine theta. You're going to put the angle here. Alright? So if this is theta, what is that? Well, if we were talking about degrees, if we were having a lesson in core math, you'll say if this is theta, you'll say this is 180 minus theta, right? You'll say this is 180 minus theta, because they're angles in a straight line. But we're working with radians, okay? We've got to get used to working with radians, okay? What is 180? Well, as I told you in the lesson, I said, you've just got to remember something like this. 360 degrees is the same as 2 pi. Just remember that, okay? Maybe that and the formula, okay? If you remember that, then you know that 180, okay? 180 is pi. So it's going to be pi minus theta. I'll write it here, pi minus theta. If this is theta, this is pi minus theta. So the formula, or the area of this triangle is going to be half r squared sine pi minus theta. Okay? That's the area. Now, I want to get rid of that pi. I'm really going to get rid of that pi. Okay? So, here I need your knowledge of trig. And again, I'm hoping you've learned that. But basically, we've got that relationship that sine 180 minus theta is actually equal to sine theta. Okay? I'm not going to explain why is the case, but I'm hoping you already learned that. If you haven't learned that, I don't know, maybe you learned in grade 12, but I'm pretty sure you learned in grade 11, okay? Or if I'm talking about radians, obviously it's the same thing. In radian will be sine pi minus theta. That is also equal to sine theta. So the formula, the area of the triangle ends up being actually half r squared sine theta. It worked out. If you just wrote theta instead of pi minus theta, you got lucky. It would be the same thing. Okay? So that's the area of the triangle. Now, let's try and find out, we'll do it in blue. No, that should have been in blue. Okay, that was in blue. That was supposed to be blue. Never mind. Okay, now let's find the area of shaded area. Okay, you know what I mean, this little bit. Now, I told you, I personally don't remember the formula for that. But what I do know that this shaded, it's the leftover if you take the segment, the area of the segment, and minus the area of the triangle. So let's just use the formula, okay? So the area of the segment is half r squared, and now I'm going to be careful. What is the angle? Well, in this case, the angle is theta, because I'm looking at this segment. So theta, that's it, in radian. Minus, what is the area of the triangle? Half r squared sine theta. Again, what is the theta? It's the angle between these two sides, so it's fine. It's like that. Okay? So that's the shaded area. Now, at this point, I think I will do as I did before. I will take a common factor. I think it will be better that I do that. So I'm going to take half r squared theta minus sine theta. Yeah. Okay. I'm hoping this is going to work. Yeah. Okay. Now what do I know? I know that this area, the area of the triangle, is 3 times this area. So I'm going to write down, okay, half r squared sine theta, that's the area of the triangle, is equal to 3 times the area of the shaded area. So 3 times half r squared theta minus sine theta. Okay, is this going to work out? Yeah, it will. Okay, now what can I start doing here? I would first of all get rid of the half. Times by 2, you get rid of the half. Just slashed it. Kill it. Okay? Next thing, get rid of the r. R squared, r squared. I'll just divide by r squared. Now let's open it. Let's open it. So sine theta equal, let's open the bracket. 3 sine theta minus, no. Okay? It's not 3 sine theta. It's 3 theta. 3 theta minus 3 sine theta. Okay? We're almost there. Can you see it now? Can you see it? All I gotta do is just move the sine theta to the other side. I'm gonna write it down here. So I'm gonna have 3 theta and minus the sine theta. Get this to the other side. Minus 4 sine theta equals 0. Okay? And that's what I wanted to show. Right? Done. QED. Okay? Alright? Hope you enjoyed. You can work on the problems. Some of them are a little bit difficult. I won't lie to you. But as I said to you in the lesson, if you've got something you're not sure about, a question you're not sure about, put it on the WhatsApp group. Maybe somebody can help you, one of the guys in the group. If not, I'll come around and I'll put an answer as soon as I can. Good luck.